Hi guys, now we come to the last part of our inequalities webinar. Just keep in mind that actually, even though we take it as an advanced application of algebra, in the second part, and that there's a lot of, complications involved, but then do keep in mind that inequalities actually are a base concept, just like we use that equal to sign anywhere, right? Anything related to math, we could end up using it. Similarly, you could use the less than or greater than sign also anywhere. Yeah, evaluate it in exactly the same way. Think about it very holistically. So inequalities, it's not just related to, let's say, that wavy line method or whatever. It will be applicable at a lot of places, and we need to look at it very holistically. So now today we're going to discuss quite a few questions where they are actually testing our number properties, but of course they have that inequality sign over there, and that is what makes us think that, okay, maybe we should try and use algebra over there. But then in case we keep our number properties in mind, I hope you guys have reviewed that, our number line module specifically, because we're going to be using it quite a lot today. In case we keep those things in mind, it'll be so much easier for us to solve the question. And that is where, that is how we say that, okay, most GMAT questions can be solved in a minute, minute and a half, because there are just so many concepts that come together. Right. So in case, we practice all of them, and in case we practice questions and then we are able to identify, okay, this is the concept that is going to be very useful over here, it doesn't take time at all in solving those questions. Yeah. So we are going to take a look at some complicated looking questions, but what I would want you to do is keep a holistic approach. That is, step back a little bit and then try to see what is given to me. This is, for example, less than that. What does it mean? Of course, the hint is already there. Try and put it on a number line. It'll become much easier. Yeah. All right. Let me share my screen with you, and we'll start with our first question. So those of you who are joining us for the first time, let me tell you how we run it. I'm going to give you a question. I'm going to give you a couple of minutes to try it out, and then we'll do it together. Yeah. After the question is done, I'll give you about 30 seconds. You can ask whatever doubts you have on that question, and then we'll move on to the next one. Okay. Just give me a moment. Yeah. As I said, it's a 30-second question. So let's see how everybody is being able to solve it very quickly and how we are actually supposed to. We should not be using algebra at all over here. So the telltale signs. If A, B, C, and D are positive integers, okay, and A by B is less than C by D. When I have a variable, let's say less than the other variable, we discussed it last time, the first thing that should come to my mind is that, okay, I'm going to put it on the number line. I'm going to put the variable on the left-hand side over here and the variable on the right-hand side over here, right? Okay, here we have a fraction. Still, doesn't matter. I know A, B, C, D are all positive integers, which means A by B is positive and C by D is positive. So then I know that I have a 0 over here, right? And A by B is over here and C by D is over here. Are we comfortable with that, right? On the number line. Where exactly, I know that they are both on the right of 0 because they're both positive, but where is 1? Because we know that in our number line, we have 4 very special regions, right? Less than -1, between -1 and 0, 0 to 1, and more than 1, right? So I've been able to mark my 0, great, and both these are to the right of that, but where is my 1? For now, I have no idea. All right. If this is known, which of the following must be true? A plus C upon B plus D. So where will we have this A plus C upon B plus D? Now, if you remember your number line, we have discussed this in rational numbers. This is this very special and very important property where GMAT is concerned, right? Guys, look, do remember that the questions of the past, they form basis for your questions of the future. So the concepts that they have discussed in their past questions, you should be extremely familiar with them, right? We do know that there are infinite properties in number properties, right? There is no end to it. But then the properties which have already appeared in the past, you have to be extremely comfortable because they'll form your basis for future questions where they'll go, one step ahead. So something you'll need to use that property and then it'll be one step ahead. So that is why we have to be extremely, extremely comfortable with the properties that they have already tested. Yeah, so we've discussed this property and this is the, okay, if you don't even remember this one, you would certainly remember the one where we talk about push and pull towards one, right? We've talked about that if a fraction is over here, one is here, and if you add the same number to the numerator and denominator, it goes towards one. And if the fraction is here, if you add the same number to numerator and denominator, and we're just talking about positive numbers, then again the fraction goes towards one, right? This is something that we have discussed a lot of places, solved a lot of questions. So this property, the push and pull towards one, is essentially a special case of a general property, which again we've discussed in the number line rational numbers part, that when when we have a fraction a by b, if I'm adding a number c to the numerator, positive numbers, and d to the denominator, what happens? Then I get a plus c upon b plus d, and this lies in between a by b and c by d, right? So it will lie somewhere over here, not right in the center. That's not essential. I don't know where, but in between a by b and c by d, right? Look, think about it. If I think about it theoretically, yeah, why is it so? Now, all right. So think about, let's say I have two numbers. A by b is less than c by d. So let's say I said this is 1 by 5, my a by b, and this is, let's say, 3 by 5. Yeah. All right. Now, in case, think about averaging. Let's say if I'm averaging the numerator, what do I get over here? I get this plus this gives me a 4. I can write my a plus c upon 2. And I can write this as b plus d upon 2, right? So I'm kind of averaging the numerator, yeah? And I'm averaging the denominator as well. So essentially what I'm getting is something in the middle, and that makes sense. It should lie between a by b and c by d, yeah? Another way in which, let's say, one fraction can be smaller than another fraction is in case it has a greater denominator, but the numerator is the same. So why are we taking either numerator denominator to be the same? Because then they'll become comparable. Otherwise, we'll have difficulty in comparing them, right? All right. So then another could be where my numerator is the same. So let me say I'll take this as 2 by 7, and let me say this is 2 by 3. Yeah. Again, what am I doing? I am, kind of finding the average of the numerator, which is 2, and the average of the denominator, which is 5. So again, this is going to lie in between my smaller fraction and my greater fraction, right? So then this is the logic. Yeah, essentially this is the logic, and this is the property that we've discussed, that if you're adding c to the numerator and d to the denominator, this fraction is going to lie in between. It's going to move towards c by d. Yeah, and this is where we get this particular thing as well, that if I'm adding the same numerator and same denominator, which means essentially I'm adding 1 to both, right? So it is going to move towards 1. 1 is just 1 by 1. So this property is just a special case of something, this generic property. Yeah. All right. So this means that this is what it is going to look like. Yeah, so then a plus c upon b plus d is certainly going to be less than c by d. This I know, this is certainly going to be true. Then a plus c upon b plus d will be less than a by b. That is not correct, because this is going to be greater than a by b, right? It's going to move towards c by d. And a plus c upon b plus d is equal to a by b plus c by d. There are lots of ways in which you can evaluate whether this is true or not. The way, just think about, let's just take any kind of numbers, right? We'll end up anyway. Look, I know that this particular thing is less than your c plus d, but this particular thing is also greater than your a plus b, right? If this is less than c by d, it cannot be equal to something positive plus c by d, right? I know that this thing is less than c by d. Then how can this thing a plus c upon b plus d be equal to, let's say, your something positive plus c by d? That's not possible, right? Because this thing is anyway less than c by d. You understand, right? And I'm making the right hand side even bigger. So that is not possible. Of course, since there is an equal to sign, there are lots of ways in which you can evaluate it. You can just plug in values and you will see it doesn't work. It's easier. Since I'm looking for a must be true with an equal to sign, anyway, it's easier for us to establish that it doesn't work, right? Harder is when I have to establish something like this. I can't just take values and establish, right? Remember, in my must be true questions, I can take values to make it, more simple for me, right? I can put in values and perhaps I'll very easily be able to find something which doesn't work for this. So I know that this is out, I know this is out, but then how do I establish that for all values this works? I have to look at a theoretical way. We talked about this, right? Must be true questions. This has to happen. All right, so that is the reason why only one must be true, which means that our answer is going to be B. Is this okay? Keep in mind, don't forget this, yeah? Keep in mind, and of course, the special case of this is this. As I said, any properties that have already been tested, they are going to be your base cases for future questions. GMAT expects you to be very comfortable with them. So make sure that at least those you are very, very comfortable with, right? And I've included all of them in the module. So if you go through it completely and you're very comfortable with it, there won't be a problem. Yeah. All right. Any issues over here? Should we go on to the next question?